Okay, 7.3, similar triangles. In chapter 4, you used the theorems of angle side and side and side angle side. Well, in theory, you're going to use them again now, but instead of being congruent, they are similar, or similarity postulate. Okay, difference. When you did two triangles congruent, you did like an equal sign with a curly line above it. Now we just get rid of the equal sign, and similar is just the curly line underneath. And here's what I was just saying a few minutes ago. If you look at the example just here, it said if angle A is congruent to angle F and B is congruent to angle G, then triangle ABC is similar to triangle FGH. Okay, and then you're looking for things. So what do you know? Let's have a look at A. If you look at what you've got, angle M is 57 and so is angle L. So in theory this has been flipped, so angle J must be the same as angle Q, which is 48, and angle P must be congruent to angle G, which is 75. Okay. Again, look on the moment, if you look at example B, parallel lines, you can look for angles. For a start, these two angles here must be congruent because they're vertical angles. You've got a pair of parallel lines, so you can have angle R is congruent to angle W. So there are things that you can do. All right, so look for those just like you did in chapter 4. Okay, so example 2, we're moving straight on to that. Side angle side. Okay, again, look for generally a flip. I mean, if you look at what you've got here, you've got vertical angles, so you've already got angles there anyway. But the one main thing I want you to look at is they are simplifying the fractions, just as I told you right back in 7.1. Okay, obviously if you've got a calculator it's a lot easier, but if you're doing it manually you need to make sure that you get it down to its simplest form. Okay, in example B, in theory you've got two triangles within triangles, so you've got AEF and ACB triangles, and again if you look what you've got a reflective property. Angle A is being used in both of the triangles. Okay, but now you need to put the sides together. Well, here's where students generally make simple mistakes. Okay, we want this length over the whole thing. Okay, and a number of times I've seen 10 over 5 instead of 10 over 15 as it should be. So it's the shorter length over the whole of the longer length. And again, simplified. So here's question number 1 all the way through down to question number 4. Okay, can you determine whether they are similar, and if so, write a statement? Well, if you look at question number 1, well, straight away you've got Z, so you've already got one angle. Can you find another angle? Well, the moment you see your parallel lines, you know you must have another angle, and it doesn't matter which one you use, but I'm using angle X is congruent to angle W, so you've got your second one. You don't go for A, remember, so don't forget now, you just write angle, similarity. Move to question number 3. So let's have a look at what you can do with this. All right, you've got 5 over 8, so we've got FG over TV. So 5 over 8. Does that equal the other side, which is 4 over 6, and does that equal the other side, which is 8 over 12? Well, the fact that this is a prime number shows that you cannot simplify that one, but these two guys actually can both go down to 3 over 2, but 5 over 8 does not equal 2 over 3, so the answer to question number 3 is just purely and simply no. I love questions like this. These are quite often in exams. It's got, you're given this figure A, B, C, D, E, and it asks you, have you got enough information, or what extra sometimes would you need? Well, again, target what you do know. You know that you've got vertical angles at point C. Okay, so you've got one of the angles. Have you got any other angles? Well, unfortunately from this, there is absolutely nothing to prove that you have got two congruent angles. Okay, but what additional information would be sufficient? Well, by far the easiest one is you need parallel lines, because if you've got EB and AD being parallel, then straight away you've got alternate interior angles. So that's the one that you need. So that will then give you another angle, and then you can prove the similarity. Okay, and properties of similarity, well, it's exactly the same as you have done for triangles and congruence, etc. Okay, the three most regular ones, and out of that, this one, reflective, as you know, is being used so many times now. Okay, but symmetric and transitive, don't forget the other two. Okay, and here what we're trying to find out is parts of similar triangles, but again, if you look at what we're doing, it's the same as what we did in 7.1 and 7.2. Putting together two fractions that equal each other, one with an unknown, cross multiplying and solving. And again, be careful, do you have to plug it back in again? Do you not? Okay, so here's question number 6, but again, make sure you put things together. Okay, J is congruent to X. So is it rotated or is it flipped? Well, if you have a look here, you've got K is 51, so Y is 51. Now we can put things together. Okay, so you've got 4 over 5, so I'm putting the smaller one over the bigger one, and that will equal X over 15. Okay, cross multiply, you've got 5X equals 60. Divide through by 5, so X equals 12. Okay, so here's example 5, a real world example. How can you estimate the height of a roller coaster? Well, you need something. You definitely need some sort of benchmark, and Hale is using herself as a benchmark. She's 5'3" tall, and the shadow that the sun makes with her at the moment is 3 feet. Okay, if the shadow of the roller coaster is 40 feet, how tall is it? Okay, make a sketch of the situation, and again, they've used this double triangle method. It works. All right, put everything back into equal fractions, cross multiply and solve. Okay, and then you can check it as well. All right, so the roller coaster, according to what Hale has done here, is 70 feet tall. Okay, so here's number 8, doing the similar sort of thing to what we've just done. You've got a cell tower that's 100 feet, okay, a 4'6" post. I'm going to put it in little 4'6" inches, and that makes 3 feet 4 inches. And now let's put it all together. Okay, so what we got? Right, 100 over, and we don't know what that's going to be, so that's going to be X, and that's going to be, the height is 4'6", let's put that into a decimal, is 4.6 feet. Okay, and then 3 foot 4 inches is 3 1/3, so we can put 3.3 recurring. Okay, so cross multiply, you've got 4.6x, and that equals 333, and if you divide through by 4.6, you will finish up with approximately 135 feet.